What if I told you that one country lifted more than 15 million cubic meters of sand and soil from the ocean floor and used it to create entirely new land in the middle of the sea? It sounds like science fiction, but this is the very real story of modern Israel. Today, we're going to unpack why Israel decided to reclaim over 100 hectares from the Mediterranean, how this massive engineering effort reshaped global trade routes, and why its effects are felt as far away as East Asia. Israel has always lived with limitations and turned them into advantages. In a country where deserts bloom with agriculture, seawater is desalinated at scale, and drip irrigation is exported worldwide, working smarter with scarce resources is practically a national philosophy. But some of Israel's boldest and most transformative projects haven't happened on land at all. They've happened offshore, where concrete, steel, and sand are quietly rewriting geography itself, off the coast of Haifa, Israel's largest northern port city. An engineering revolution has unfolded over the past 2 decades. The goal was singular and strategic: make trade with Asia faster, cheaper, and more efficient. To understand why this mattered so much, we need to rewind to the early 2000s. When Israel faced a growing logistical dilemma. Trade with Asian economies, China, Japan, South Korea, and others was accelerating rapidly. By that point, Asian goods already accounted for roughly a quarter of Israel's imports, from electronics and textiles to heavy industrial equipment. All of it needed to enter the country somewhere. At first glance, the solution seemed obvious. Israel already had a port perfectly positioned for Asian trade. The port of Eilat on the Red Sea. Ships from East Asia could pass through the Suez Canal, cross the Red Sea, and arrive at Eilat with minimal detour. On paper, it was the shortest, most efficient route possible. But reality had other plans. The problem was scale. Global shipping had changed. Modern container vessels, especially post-Panamax ships, had grown enormous, capable of carrying up to 15,000 20-foot containers in a single voyage. These giants required deep water, with drafts reaching 15 meters. Eilat's port, however, offered depths of only about 10 meters. Simple math made the limitation unavoidable. These ships would run aground long before reaching the docks. Modernizing Eilat wasn't just a technical challenge. It was a minefield of environmental, economic, and geographic problems. The Gulf of Aqaba is home to one of the northernmost coral reef ecosystems on Earth, a fragile and irreplaceable natural treasure. Large-scale dredging would have released massive clouds of sediment, smothering corals and disrupting marine life that had evolved over thousands of years. Environmental groups pushed back hard, and for good reason. Even if those concerns had been resolved, the economic consequences would have been severe. Eilat had long since reinvented itself as a tourist paradise. Hotels, beaches, dive centers, and restaurants defined the local economy, turning the coastline into an industrial construction zone filled with dredgers and container ships would have devastated tourism almost overnight. Then there was geography. Eilat sits in Israel's far south, more than 250 kilometers from the country's main economic hubs, Tel Aviv, Jerusalem, and Haifa itself, where still there was no direct rail connection. Cargo would have needed to cross the Negev desert by truck to reach the nearest railhead, dramatically increasing cost. Building a railway through the desert was theoretically possible, but the price tag would have been astronomical. Faced with these realities, Israeli planners made a bold strategic pivot. Instead of forcing Eilat to become something it couldn't be, they would shift the focus to the Mediterranean coast. The route from Asia would be slightly longer, but with the right infrastructure, the gains would far outweigh the distance. And so attention turned to Haifa. Haifa already had several key advantages: proximity to Israel's industrial heartland, existing rail and highway connections, and room to expand seaward. In 2005, the first phase of a massive modernization effort began with the construction of the Carmel terminal. To make it possible, engineers had to solve the depth problem head-on. Specialized dredging vessels moved in, working relentlessly day and night. Multi-bucket dredgers scraped the seabed like underwater excavators, lifting sand, silt, and rock and transferring it onto barges. Suction dredgers followed, using powerful pumps to vacuum up sediment and water, storing the mixture on board before transporting it for unloading. By the time Carmel Terminal was complete, more than 2.5 million cubic meters of material had been lifted from the Mediterranean seabed dock. Instead of discarding this material, Israel chose to reuse it. An area of roughly 225,000 square meters was reclaimed from the sea. Engineers surrounded the site with steel retaining walls, forming a protected basin. Inside, sand was laid layer by layer, compacted repeatedly and fitted with drainage systems to remove trapped water. Only once the soil reached the required density did construction of massive concrete foundations begin. By 2010, Carmel Terminal was operational. With berth depths exceeding 15 meters, it could accommodate post-Panamax ships carrying over 15,000 containers. But this was only the beginning. In 2015, construction began on an even more ambitious project, Bayport Terminal. This time, the scale was staggering. More than 15 million cubic meters of seabed material were dredged 6 times the volume used for Carmel. Of this, 10 million cubic meters went into creating a new artificial island covering 84 hectares. The engineering techniques were refined further. Temporary internal partitions allowed precise control over soil settlement. Advanced compaction methods ensured stability, while extensive drainage networks accelerated consolidation. Once complete, the island was topped with foundations strong enough to support some of the largest cranes ever built. Bayport was designed for the future. With depths reaching 17.5 meters, it could receive ultra-large container vessels carrying more than 18,000 container ships over 400 meters long. Automation became central to operations. Robotic cranes, automated container yards, smart truck gates, and direct rail connections transformed the terminal into a logistical powerhouse. Protecting all of this required another massive undertaking: a new breakwater system. The main breakwater was extended by nearly 900 meters, and a secondary barrier more than 2 kilometers long was built using reinforced concrete caissons and millions of tons of stone. These structures absorbed wave energy, protected against storms, and prevented sediment buildup inside the port. The payoff was immediate. Haifa's throughput capacity surged to around 1.5 million containers per year. While modest compared to global giants like Shanghai, it was transformative for Israel. Ultra-large vessels reduced shipping costs, lowered consumer prices, and turned Haifa into a regional transshipment hub serving Greece, Cyprus, Egypt, and beyond. Thousands of jobs were created. Entire logistics ecosystems emerged, and northern Israel experienced renewed economic growth. What began as a response to trade pressure became a case study in how engineering, strategy, and long-term planning can reshape geography itself. Today, when massive container ships dock at Haifa's artificial shores, few people stop to consider that the ground beneath them didn't exist a generation ago. Yet this man-made land stands as proof that with vision and determination, even the sea can be negotiated. If you enjoyed this story of humanity's ability to bend nature through engineering, subscribe to the channel, hit like, and tell us which mega projects around the world impress you the most.